avoid putting us on hold. I'd like to get started with our first speaker, Ron Williams, who's a research chemist with the EPA's Office of Research and Development's National Exposure Research Laboratory. So, Ron, I'll turn it over to you and start your PowerPoint presentation.
Very good. Well, I'm very happy to be here. We're excited always about sharing what we're doing in terms of emerging technologies. As you can see on the next slide, we're investigating across a broad area of trying to provide feedback to a large group of stakeholders. And our stakeholders include you and citizens and community action groups and regional authorities and other aspects of EPA and sensor manufacturers. And we're doing that by, one, trying to determine what's out there. We typically get asked multiple times every week, what sensors are available, what are the purpose of those sensors, can you tell us anything about them? And that understanding the market is a vital part of what we're doing, and some of that is by direct investigation, and other times it's opportunistic where manufacturers will say, hey, we've just developed something, and here are the spec sheets. And so it's a continual process that we're engaged in. One of the ways that we're doing that is looking at professional literature as well as anecdotal information. In all honesty, there is not a lot of technical information about what we might call the low-cost sensor area, and those are sensors will be typically described costing less than $1,500. That is typically just a cap that we see that most citizens and community action groups just can't afford to go over, so we're trying to focus mostly on those what we call the low-cost sensor areas. And some of the ways that we're doing that is item number 4 there on that list, and that's developing user guides. Amanda and I have been extremely busy over the last year and a half that when we entertain a sensor and we have an opportunity to evaluate it, in many cases we're actually trying to turn that around into a citizen science operating guide so that others who might purchase sensors not having a technical background have the ability to go there and operate it to some satisfaction, because we have a saying, bad data is bad data, and regardless of what sensors manufacturers may say about the ability of a device, if one operates it poorly, then one's not going to receive good data. So we're, as many times as possible, trying to provide user guides, and Amanda can give you information about that in our upcoming slides. We're also spending quite a bit of time talking to others about what the sensor manufacturers are doing. In many cases, they often don't know what's needed. They don't know the criteria pollutants in many cases. They're not really sure whether benzene or toluene or T-butyl ether or whatever it may be. What is that we're interested in the EPA? What are citizens interested? In many cases, manufacturers don't know that, and we're able to explain to them from the EPA point of view where our interest is, and based upon the feedback that we get from citizens and others where we see that there might be a need for them to invest their time and energy. And, of course, we're spending quite a bit of time with investing ourselves across EPA on item number 9 there. It's not just those of us here locally in the program that I lead, but there's others inside the agency across EPA in our regional office, as well as those in state and local air quality boards, because we believe everyone has a stake in the sensor research area. Ultimately, all of us have to go there and try to figure out how do we use this data, so we try to do that in a collegial, collaborative fashion. On your next slide, I'm going to turn things over to Amanda Kaufman. As I said earlier, we're trying to get a lot of information out, and I'll let Amanda talk about our next 2 to 3 slides.
Okay, thank you, Ron. So in an effort to address the growing field of citizen science and air monitoring, back in July we hosted the community air monitoring training, and that was to share tools, best practices, and resources from EPA's Air Sensor Toolbox for citizen scientists. And I'll tell you a little bit more about the toolbox on the next slide. The goal of the training was to educate interested groups and individuals on how to conduct successful air monitoring projects. It was unique in that the training was attended in person by 30 community action group members from across the states, including tribal groups, and then over 800 individuals via webinar. we had multiple videos that were recorded of the 6 presentations from the morning. Ron was involved in 2 of those presentations, including air quality monitoring and sensor technologies, as well as quality assurance. And those videos are available for anybody to watch on the URL that is here at the bottom of the screen. And the nice thing about the videos is that they're short and sweet, and they're about 15 to 18 minutes each, and they provide a nice basis for anybody who's interested in beginning their research or learning more about quality assurance or data quality and things along those lines. Let's move on to the next slide, please. So here is the URL for the Air Sensor Toolbox you see here on this little business card icon. I encourage you all to visit this. We are constantly adding new resources to this web page. And basically the toolbox is a resource for web access for public resources, including the videos that I just talked about, as well as things such as the Air Sensor Guidebook, which is a great resource A to Z. What is air pollution? How do I choose a sensor? What sensor considerations do I need to take into account when I'm, conducting an air monitoring study? We also have information, the performance evaluations from different evaluations that we've done here at EPA related to particulate matter sensors, VOC sensors, ozone, and NO2. There's also information for interested parties who would like to find funding opportunities. And like I said, we're always updating this, so just feel free to check back at any point and you might find some new resources. Next slide. And I'll turn this back over to Ron.
Thank you, Amanda. We're going to spend the remainder of our time here on a technical note, trying to give you feedback and an understanding of what we see the state of the science. And we always like to start with this slide because if you're interested in measuring any of these criteria pollutants and other pollutants of interest, like black carbon or volatile organic carbons, it's good to know what do you need to be able to measure, what are the sensitivity levels that you need to ascertain. The vast majority of sensor technology that is being released and sold, you're not going to be able to go there and find typically what we might call a specification sheet, where the manufacturer knows that it has the ability to measure at 1 part per billion, or it has a precision of 5 or 10%. That currently just doesn't exist except for rare instances. But you need to know. You need to know that in many instances, if you want to measure ozone in, let's say, a non-industrial application, you really need the ability to measure at least at 10 part per billion, or maybe even a little bit lower to get adequate data quality. And so when you start thinking about purchasing equipment and devising field studies, this is a very, very useful table because it gives you an idea, okay, I want to make sure my device has the ability to be useful. Again, if you collect data where the device doesn't have the ability to detect at the concentrations that we call environmentally relevant, then you ultimately will not have any data of useful consequence, and you don't want that. So data sheets like this are very, very helpful. Let's look at your next slide. You're going to see a listing of some sensors here for the next couple of slides. Again, we don't recommend any sensors. EPA and the government's not in the habit of doing that. In fact, we're forbidden from doing that. But we often get asked that question, what sensors are useful, Ron? Well, we can tell you via what we see in our published reports and in the reports of others. And if you go to the next slide, you'll see that sensors, come in a wide range of capabilities. Some of them come in near weatherproof condition where you might be able to place them out without any additional weather shielding. But many of them, as you can see here, if you put the Sensaris out, or if you put that AirQual, which really is just a board, a printed circuit board, of course you couldn't put that out in a wet environment. You couldn't put it out where there's going to be snowfall. You might not be able to put it out where there's direct sunlight. And so the vast majority of the sensor technologies that are being released by the manufacturers are not really meant to be put directly out when you purchase them. In many cases, you're having to put them underneath a shelter or protect them from the weather. But this gives you an idea of the range that we see. Many of these right here are the size of your hand. They may weigh 2 or 3 ounces, and they have varying degrees of performance. Let's look at your next slide. when we approach this, we do the hard stuff. We'll actually take sensors and we'll put them in chambers and we'll actually challenge them to concentrations. And we've actually been encouraging manufacturers to do the exact same thing because, again, many of these are being released on the market without any knowledge of what they can and cannot do. It's been our observations that in many cases, sensors that we have purchased for testing not respond at all. They virtually have no response or respond maybe at 1 or 2 orders of magnitude higher where the concentration is not going to be. In other words, they're so insensitive, they're not going to do you or I any good, and the manufacturer in many cases just don't understand that. Many people don't have the ability to do chamber testing like we do, but when you think about picking out sensors and designing your studies, these are the types of questions you want to ask manufacturers. Have you evaluated your sensor? Do you have the ability to calibrate it? Next slide. A lot of the ways that we go there and evaluate sensors are in those chambers, or we put them outside in real-world environments. Here you'll see a test case. This happens to be on the EPA RTP campus. We do that in coordination with work by the Office of Air Quality Planning and Standards in a collaborative fashion. And we put sensors out and we directly compare them to FRM and FEM. And as tribal nations, you're well aware of FRM and FEM status. You know what's required to do that. And so while we're testing these systems, we're not trying to go there and establish them as FRM or FEM. But that being said, we want to know how they compare because, again, if they have the ability to go there and provide supplemental data for our purposes, if they have the ability to go there and be sentinel monitors, what better comparison than directly comparing them to reference monitors? And here's a way that we can do that, and it's a fairly simple setup where we have metal helmets, we might call them, or bowls, and the sensors are placed underneath that where there's good air movement. And you likewise could do similar stuff in establishing, let's say, co-located measurements. Let's look at your next slide. As I've said earlier, there are a wide host of sensors that are available. I'm currently involved in a 9-month study in Denver where we have what we call a chicken coop, and it's a very large metal structure with wire screens where we have a large number of sensors being evaluated all at one time. These are some of the more prevalent sensors that are on the market. You see the air beam particle sensor. That's a PM monitoring device. You see the air quality eggs. That's those white egg-shaped containers in the middle of the screen. Those green circuit boards, that's the air qual ozone card. Those black boxes in the back are Dylos monitors, and behind those Dylos monitors are MET1 831. Those are PM monitors. And in the far lower left-hand corner, those are care clips. And care clips come in a variety of shapes and fashions. These are the most prevalent. They're about the size of a roll of quarters, and they have the ability to measure different models, NO2, ozone, hydrogen sulfide, and even VOCs, and even PM. So it's a widely applicable device for different things. One can go there and spend as low as $100 to $200, say, on some of these air beams, to as much as $10,000 on that AQ mesh pod you see in the upper left-hand corner. That's a pod that is sold out of the UK. It's distributed here in the United States, and it literally costs $10,000. The inside of that device is actually containing a lot of the same instrumentation you see in these pods here, these devices that are here. So, you have to understand what you're getting, and the best way to do that is have very frank and open conversations with manufacturers about what type of technology are you embedding in your device. Next slide. Again, if you think about doing work, co-locating it with reference monitors, there's a lot of ways of doing this. Just gives you an example of what our chicken coop looks like. Again, it's a structure that shields devices from the wind and the rain while allowing good air quality movement. Again, for some of these sensor devices that are low cost, $100 to $100, $200, $500, $2,000, so forth. Again, the vast majority of them are not weatherproof, and you have to find some way of getting them in the environment while protecting them. And so this is just one option, and we're just sharing it with you as an example of weatherproofing. Next slide. Well, how well do some of these devices work? Again, as you heard from Amanda, we invite you to go to the Toolbox website because literally, typically within about 30 days of completing our exams, Amanda and I can turn a report out in about that period of time, and we get it out in the literature after it's peer reviewed so that you can see it. And in many cases, some of these devices are showing some promise. For generally on the PM side of sensors, we typically see the very best ones coming into an agreement with reference monitors about 60 to 70% of the time. That being said, all of them are co-responsive with relative humidity, and when you get these PM sensors in and around anywhere from 85 and higher, they start responding exponentially and in a positive bias fashion. In other words, they're giving a false positive, typically some cases an order or two higher than what the real concentration is. So again, under conditions below 85%, many of these PM devices will get you in the ballpark of what the reference monitor is doing, but you always have to be respectful of relative humidity because they don't have the ability to correct for that influence. Next slide. How about some of the other sensors? Well, we certainly have kind of what we call a rule of thumb, and if you're taking notes at home, we typically find that the low-cost sensors, that the ozone monitors that we see under $1,500, a vast majority of them actually perform quite well, and it's not unusual for ozone monitors to be in agreement on 90% with what a federal reference monitor is doing. That's pretty astounding when you can take a $500 ozone card, compare it next to a federal reference monitor, and get those types of results. We typically see ozone being some of the best agreement, typically followed by nitrogen dioxide sensors. Here you see an example in the slide. This was a sensor box that we, in collaboration with Region 2, built and provided to citizens in the Newark, New Jersey area. And you can see by looking at the blue lines and the other lines here how well, in most cases, they responded. In other words, we were able to get very, very accurate results of NO2 with a device that cost about $1,100. Once we co-located it and normalized the data, it responded lockstep with the reference monitor the vast majority of the time. And so there is hope that some of these devices, including NO2 devices, can, again, be excellent devices to give you sentinel understanding where you can get a general understanding of what is going on. Again, non-reference, non-equivalent, but they can get you in the ballpark. But not every device is the same. So I don't want you to think I'm saying all NO2 devices are equivalent. They're not. How about the next slide? Again, that Toolbox website will give you a great understanding in detail of how various sensors compare. Here you see a general summary of some of the PM sensors, and if you just follow the line that says FEM PM 2.5, that's the federal equivalent monitor. This is for almost a year-long study where we've had these sensors co-located in Atlanta, Georgia at a state reference monitoring site, and you can see that the agreement, the Pearson correlation, changed quite dramatically across the various sensors that were operated. And I just invite you to take a look at this slide. What we typically see is that for any grouping of sensors, they typically operate very much the same. In other words, if I have 3 Dylos sensors, they typically will operate within about 10% of one another. That being said, if I'm comparing Dylos to some case like the air quality egg, and you can see those didn't compare well at all. And so, again, typically groupings of sensors typically are reproducible, but one should not expect a single sensor to be equivalent to other sensors. And we often find quite dramatic differences in the same type of sensor technology. Next slide, please. Where everybody's interested in VOCs, we've done a huge amount of work on that type of technology. That being said, there just are not a lot of low-cost VOC sensors that are available. Here you see some of our laboratory work that we've done. We've compared what we consider some of the best available throughout the world, and we literally tested units from Italy, Spain, Germany, and in the U.S. We really scoured the market to try to find devices under $2,000 in this case. We did see one device that at about 20 part per billion, this is a device from Italy that it actually responded in good fashion to our challenge concentrations. That being said, this is measuring benzene. the vast majority of us will never see benzene concentrations at 20 part per billion in our backyard. We're much more likely to see benzene concentrations below 1 part per billion and maybe even in the tens of trillions. And so it's just not a likelihood that a sensor like this will have a great deal of application except in areas where you're getting much higher concentrations around a source. Next slide. We've done a fair amount of work with citizens and other groups and actually taking some of these sensors and actually trying to apply them. Here you see some of the care pulse sensors where we actually are measuring a combination of ozone and nitrogen dioxide and then comparing that versus a true federal reference method. And if you just follow the red line there versus the black line, you can see that an $1,100 device at the end of the day did extremely well in the hands of citizens and actually understanding their local environment. And this is just one of a number of cases in which we've been able to do that. Next slide. I invite you to think about the fact that you may need something very specific for the work that you want to do, and this really depends upon your ability to engineer or to engage engineers in building a device that you might want to use. This is a sensor pod. This is one that we developed for our Region 2 friends and citizens in the Newark, New Jersey area, and we actually built a device that had the ability to measure PM 2.5 at a true cut point, as well as measure NO2 simultaneously, as well as relative humidity and temperature in a weatherproof encasing, and which could operate for 7 days unattended and would store data in a straightforward manner. And so when you think about the work that you want to do, yes, there are manufacturers that will sell you a device. You may not need just a single device. You may need a pod, a multi-pollutant system. And so sometimes you have to kind of think, strategically, do you want to spend $500 on a sensor, or do you maybe want to spend $5,000 on a sensor pod and collect more information? Again, it requires a degree of engineering ability or ability to gain engineering principles where you can go there and actually integrate systems and apply voltages and secure data storage systems. But again, that's what you may have to think about when you start doing things away from power sources and where you need to work in a more portable fashion. Next slide. And one of the things that we're trying to do is share quite a bit about our Village Green system because, again, you may need something that's of a higher quality. All the information you've seen in these earlier slides, we're talking about sensors that, again, cost less than $1,500. You may actually want to consider purchasing devices in the under $10,000 range, which in all honesty, you typically are getting what you're paying for. But we have found multiple sensors in that $5,000 range that have shown quite a bit of promise. We've instilled those in our Village Green systems for both ozone and PM 2.5. And if you happen to go just to that website, the Village Green, if you just Google US EPA Village Green, you'll see data right now coming in from Philadelphia and Washington and Kansas City and Oklahoma. Soon stations in Chicago and in Houston will be coming online where we're producing data every single minute for the general public in a stationary fashion powered by the sun. And when you think about setting out stations, you have to think about what is the energy supply that I'm going to be using. Am I willing to go there and bring batteries to a station? Am I willing to go there and try to find land power? Or can I think about using solar power to go there and power some sort of a measurement device? And the Village Green is what I would consider a very upscale monitoring because, again, it has the ability to be self-powered, but it's also producing very, very high-quality data. Again, non-regulatory, but data that's of good quality. Next slide. And so that's the end of what I wanted to share. I know we wanted to save time for questions and answers, and Amanda and I will be glad to do that.
Great. Thanks, Ron. As you said, let's open it up for any questions for folks have. And if you're on mute, you can unmute by pressing *6.
Hey, this is Craig Creeman, Quapaw Tribe. Hey, Ron and Amanda, I got a question, maybe just a general question, but you talked about the 90% agreement with a lot of the ozone portable sensors, and just recently, I think back in October of 2015, Teledyne was granted FEM status for a Model 430 compact. Is that something that could probably happen with quite a few these portable sensors here in the future, as their agreement's so close to that 90%, 80-90% that they eventually will turn into an FEM approved monitor, or what's kind of EPA's thought on that?
Well, there is a formal process for, of course, FRM, FEM, and that hasn't changed, and I don't believe anybody has any intentions of that changing anytime soon. It's a promulgated standard, and it's a great standard. We have had some sensor manufacturers who have actually submitted sensors, in some of those cases sensors in the $6,000 to $10,000 range, where they have actually applied for FEM review. And to date, we have one ozone device. You may have heard about the POM, the Portable Ozone Monitor, which actually has received FEM status. And I'll caution that by saying the technology has received FEM status, not its full application, because when we think about regulatory monitoring, of course, there's a whole guideline in terms of how we collect regulatory quality data. But the technology that's in the POM, the Personal Ozone Monitor, has been reviewed and under at least some conditions has been shown to be of value equivalent to an FRM. But again, it's not necessarily just the technology, but how that where that device is being used and how it's being operated. So it's just a word of caution there. But we would think that is the first of others that will try to do likewise. It is a very, very high bar because, again, regulatory quality data has to be of the highest quality and it has to be, foolproof. But we do see at least one example, and 2B Technologies has created an ozone card. In fact, what we have in the Village Green stations is an ozone card manufactured by 2B. That technology likewise has been evaluated and would appear to be well down the road toward maybe meeting FEM requirements. And so, again, we think that threshold is being met by some manufacturers. Again, not just for the technology, but again, one also has to be considered how you're operating because they have to go hand in glove. But we're not changing the standards because new technologies are coming out. New technologies will always have to meet the standard.
Thank you.
Great. Any other questions for Ron or Amanda?
As a postscript, as you think about work that you want to do, Amanda and I we entertain conversations every week with multiple groups, and we'll be glad to continue conversations. When you actually start thinking about planning studies, our number is available. You can contact me. We'll set up a conference call. We'll go there and try to go over with you any updates on technologies. Again, we can't recommend devices. We can't pit one manufacturer against the other. We can share with you what we've learned about technology in a public forum, and we'll be glad to go there and do that. Any way we can be of assistance.
Great. Thanks, Ron and Amanda. If there's no other closing questions or comments, we'll move on to our next presenter. Great. Well, at this point, I would like to introduce Ben Benoit, air technician with the Leech Lake Band of Ojibwe, to discuss a pilot study at Leech Lake utilizing personal air monitors. So, Ben, are you on the line?
I am.
Great. Go ahead. I'll start your PowerPoint presentation.
Okay, great. Thanks, Andy. Yeah, like you said, I'm the air technician with the Leech Lake Band of Ojibwe, and today I'd just like to go over kind of the pilot project that we have going on with the EPA and Sonoma Technologies, revolving around a few of these sensors that Ron touched on, and maybe I'll go a little bit more into. So you can go to the next slide, Andy. So some of the background is that this project was designed to test some of the low-cost PM sensors to answer some of the questions that we had as a tribe. And the study is really going to be done in two phases. We started on the first phase now where we've co-located the sensors that the EPA provided and that we managed to procure one ourselves with our FRM, Federal Reference Monitor, that's located at our air site here, kind of outside Castle Lake. The second part of the study would be mobile monitoring, where we position these sensors near local sources and just to see if they could measure the impacts that we're seeing on the local air quality and find gradients based on that. So you can go to the next slide, Andy. So some of our objectives of the study was that we wanted to be able to assess how good a data we're getting in comparison with our FRM monitors for these low-cost and medium-cost sensors, and then build up a database so that we could get some analysis off the back end. Currently, we're still gathering the data, and once we've compiled it, we'll start on the data analysis. Also, we wanted to determine some of the limitations that these sensors have. Like Ron mentioned earlier, when we get these sensors, they're more designed to sit on your body and be carried around indoors and monitor air quality that way, not necessarily sit outside in cold Minnesota weather, winter. And we wanted to see how they'd hold up being subject to the climate up here. So we built a small shelter, and then we wanted to see how they'd function inside of that. So you can go to the next slide. So our air site, this is where our FRM monitors are located. There's power there, but we don't have any communication with the air site. So every week, myself or Brandy or some of our other staff will go out there and do weekly visits. We have our FRM PM monitors there. We also do run an NADP mercury site, and we have a meteorological tower there. There was no shelter initially available, so we had to come up with something with the help of Sonoma Technology to house the sensors. And we're downloading the data on a weekly basis from a computer that we have set up there to get all the data off of it. And I can talk a little bit more about that as we talk about the sensors. So moving on. Okay, so this is one of the sensors that we have out at the air site. This was provided by the EPA, and it's the RTI micropem. This reports the concentration in micrograms per cubic meter, and we get results every 10 seconds. The nice thing about this sensor is that it's got an internal memory. So you don't need to have it hooked up to anything to data log, which has turned out to be quite useful, especially in our study. It's on the more expensive end of the sensor. It's $2,900 roughly, but it's pretty durable, and you can calibrate it. It comes with software. Looking at the picture here, you can kind of see the device itself on the upper right. The few buttons, a couple lights. Its interface isn't all that great, but it interfaces with the computer pretty well, and it's pretty usable once you have it hooked up to that. Right next to, in the middle, top middle, is the inside of the device, and you can see it has batteries. While it's hooked up at the air site, we have it charging all the time, but the backup batteries have been nice, although they've caused a bit of headache with keeping time and some of the issues that we've run into it because of it. It also has, looking down at the bottom, all the pieces that came with it. So this is a device that you can calibrate. You can see there's some tools to calibrate it with. There's some flow rate stuff. And every week at the air site, we've had to go out, calibrate this, change the filter on it, but it's functioned pretty well. Moving on to the next device. Next slide, sorry. Is the AirBeam. So the EPA provided 2 of these for us. This is not as an expensive device. It's pretty low cost. I think they're around $250, but you could tell just by holding it that it's a little cheaper. It reports its data in particle counts, so we've had to convert that data into micrograms per cubic meter to actually compare it with the FRM. And I'm pretty sure this one is still being evaluated by the EPA. You can find information on this one on the Citizen Science website. This one doesn't have an internal storage method. So while we've been collecting data from this, we've had to keep it hooked up to a computer. There was a lot of work trying to get software that could interface with this and then data log the data as it's being produced. It provides a particle count every minute, so it doesn't provide as much of a data set as the micropem does. But it provides for good mobility, and it can actually Bluetooth with your phone or your laptop or anything that has Bluetooth and can run the aircasting app. So at the top is a picture of the device itself, and then underneath it is just some screenshots of the aircasting application on the phone, which works pretty good. We warm around the casino locally here and kind of got some small data sets just from there, and it was pretty surprising to see how the smoking is and how it popped up right away as soon as we walked in there. Once you make a session with the device, you wear it around, it records the data on your phone, and then you can upload that to the cloud through the app on the phone. We've had a few problems with these devices. I don't know if it's because of the quality of the device itself or other issues, but we've run into problems with them running probably due to the weather. But it seems like every week we're having to get these things working again. So moving on to the third sensor we have at the air site. So this is the MET1 neighborhood monitor, and you can see a picture of it on the left. It's a moderate cost. It's around $2,500, but MET1 graciously donated one to the study, which we're very happy for. And then this device does not have internal memory. What it does is it uploads data every 15 minutes to the cloud through a cellular network. So included with the cost of this is 2-year service plan with, I think it's AT&T or T-Mobile, whichever service provider you choose. But that's included with the initial cost. And if you go to that web page, on the right here is a kind of a screenshot of the web page that they provide with the device. So what I'm having here is Andy pull up kind of today's real-time neighborhood monitor web page. So on the right, you can see the concentrations are uploaded every 15 minutes. I sent them this one a while ago, so it's probably not refreshed. But you can see today we're kind of having a small event, which we actually see on our forecasting, too. We do forecasting through Sonoma Technology, and today is a moderate air quality day with an AQI of 59. And that's reflected through our neighborhood monitor. You can see earlier today we were in the 20s, and it kind of gives you a nice graph. It holds about 2 weeks' worth of data online that you can access and download if you wanted to. Also, there's a map where it should pop up in Minnesota, but for some reason our map hasn't updated since we've put this into the field. Yeah, I called that one earlier to try to get it to update, but we haven't heard anything back. So you can go back to the presentation now. And this also reports in micrograms per cubic meter for a direct comparison with our FRMs. This is probably my favorite device just because of what we're trying to do with this study. But it contains everything that you need just to set it out in the field and do ambient air quality right away. Moving to the next slide. So here's pictures of our sensors as they're in the field. On the left, you can see the housing that we've created for the sensors. It's actually a kitchen wok that they turned upside down, and then we fit the sensors into it. So on the far right, you can see kind of an underneath view. So the micropems on the left of that, and then the 2 air beams are on the right side of it. And then in the white box is the computer that we have them all hooked into that data logs, and we download the data from weekly. In the middle picture, you can see our sensor stands there, and then the two FRMs are in the background. So we tried to put them all at the same level to get a good co-location. So moving on to the next slide. So some of the things that we've learned to date on the study. We initially set up the sensors in late October, and we initially ran into some micro-PEM calibration issues, which seemed to be related to the software and kind of some getting used to the technology issues. Also, we had some problems with the time not being kept. Our cord went bad while I was out in the field, and then the batteries went dead, and we kind of ran into some issues where it didn't remember the timestamp. So we had to sort all that out to make sure that the data was getting accurately retrieved and with the right time on it. One of the air beams that we got doesn't seem to operate in the field at all. I mean, we'd set it up, we'd get it working, and then several hours after we left the field, it would go dead or it would stop working. We've kind of attributed it to the cold weather of Minnesota. The other air beam seems to work great, but for whatever reason, air beam A just wouldn't work like air beam B did. That sensor has been actually removed from the field since we can't do anything with it, and it's right now at my house doing a fireplace study. So we've lost some data because of that, and we haven't really been able to get a lot of data for the air beam on air beam data set that we were hoping to build through this study. Another lesson that we learned is that when you're picking your neighborhood monitor, you need to choose the network that you're associating with it wisely. Initially, when we got our neighborhood monitor, we had picked a T-Mobile network, and we were only getting data every other day for really spots of it. And we had to call Met1 and send it back and get a different one sent out that used a different network, and now we're getting a really good data set from that. It's been great. Next slide. So some of the future that we see for this study is that we want to continue the field deployment and co-location of the sensors and then move into the mobile monitoring portion, hopefully before the end of February. Once we've got the data set, we'll be able to dive into it and really come up with some of the final conclusions of it. We hope for 21 comparison data sets, and that's with the FRM. We do a 1 in 6 cycle, so from October to February, there was 22. We've already lost one of those data sets, but we're hoping to get the other 21. It's a highly anticipated study. Brandy hopes to present something at NTF this year, and we've been fielding questions on it already. So moving on. And then this is a picture of us working at the air site in the snow. If anyone has any questions, myself or Brandy, and our contact information is there. And I'm willing to answer, with Brandy's help, any questions you have right now.
Great. Thanks, Ben. Are there any questions or comments?
This is Ron. Just for everyone's edification, we've actually tested all of these devices, but in our hands to date, we've yet to have a device provide a better agreement than the RTI micro-PEM in our field test. As was stated, it is one of the more complicated devices, but in our hands, it's shown to be also one of the more accurate day in and day out.
Great. Thanks, Ron. Any other questions or comments? Great. Well, thanks, Ben. And as a reminder, we'll have some time at the end if folks have questions later they want to ask. At this point, I would like to introduce Craig Creeman, who sits jointly on National Tribal Air Association's Executive Committee for Region 6 and is the chair of the TAM's steering committee. So, Craig, go ahead.
Thanks, Andy. And first off, Happy New Year, everyone. And again, thanks to Ron and Amanda from EPA talking, as well as Brandy and Ben from Leech Lake. When I first found out that those guys were going to do a study, I was pretty excited just to kind of see them get going. And now that they're getting some results and kind of working out some of the difficulties, it'll be exciting to see them present that at NTF. And with earlier, Ron had spoke to the July in-person citizen science. We had a steering committee member actually attend that and able to give us a lot of good feedback from that, and kind of spurred and kicked off some of the good talk the steering committee had on pushing forward on some of the sensor technology. We continue to look at that sensor toolbox site. As Ron said, it's continually being updated with new information, which is great as we're moving forward on really trying to find good sensors that we could hopefully here in the future utilize at the TAM Center. And just recently, the TAM Center had the opportunity to purchase some sensors that Chris Lee and Farshid will present on here in just a moment. But again, we're excited to get them to the TAM Center and start seeing how these sensors can benefit tribes in air quality with their distinct issues that they have. So I'll turn it over to Chris Lee and Farshid with the TAM Center.
Alrighty, Craig, thanks. Hey, Andy, for your information, I was unable to get onto the webinar, so I can't see what you're presenting. But I do have my presentation open on my computer, and it's the same one that I sent to you. So go ahead and move to that second slide.
Okay, you got it.
Okay.
So brief history.
Okay, cool. The right one. Just for everybody's information, about a year ago, the TAM Center was given information that we had funds remaining in our Tribal School Air Toxics Monitoring Initiative support that we were providing, and that there was a possibility that those funds might get swept. And so through some quick meetings that we had with our steering committee, they basically recognized that a good way to maximize the use of the funds that we had available through our TAM Center was to secure some kind of quick deployment screening devices, such as these sensors. And since that technology was new, and it was there was more discussion on the use of the sensors as good monitoring devices, we decided to move forward with securing some of the sensors. And so with some research, we selected the AirQual Series 500 sensors. They were all ozone sensors, 4 of them. And also we purchased some NOx sensor heads for those sensors. And the reason why we chose the AirQuals was because they had really strong correlation values, good R values. And so we felt that they would be good support for folks using that equipment out in Indian country. And so we purchased those. Unfortunately, we're still awaiting shipment right now, but I want to give you at least an idea of what we're doing right now, in hopes of having those available for loan here in probably this year sometime time frame. So next slide. That is the AirQual sensor that we purchased. It's, as you can see, it's a handheld device. It's going to have an outside enclosure that we also purchased, so you can locate it in an outdoor environment and for safety. And so those, again, we'll have available as loan in the future here. Next slide. And what's going on with our current activity is the TAM Steering Committee has begun work on a support strategy document, thanks to Craig. And with that strategy document, we've purchased the sensors. We're in the process of getting some standard operating guidelines for the equipment setup. Basically, the SOGs are less formal standard operating procedure, and these will accompany our equipment when we're ready to have it loaned out. But prior to loaning out the equipment, we're going to co-locate, do basically a test study with our sensors that we receive with tribes who have FRM air monitors, co-locate those in various regions of the country to determine the reliability of the data, and hopefully have some good information for folks who want to use the equipment. We'll finalize the development of those SOGs and begin loaning out those sensors. And I think we're still in discussion right now with regards to what our time frame for loan of the equipment is. And as you've heard from the previous presentations, these are really more of screening devices, and so it's to give folks an idea of what they're seeing, and if there's elevated levels, then you can use this information to make a case to get more comprehensive monitoring done. And that's basically it with what we're doing right now. We really hope to get those in here shortly. It's taken some time. There's been a lot of hang-ups when it comes to that procurement process. So that's where things are right now. Go ahead and move to the next slide. And that's it. If there's any questions, please feel to call either me or Farshid, or you can also talk to any of our TAM steering committee members for any additional information. And that's it. If there's any questions, or Craig, if you have anything else to say.
Great. Thanks, Chris. So any questions or comments?
No, this is Craig. I just wanted to comment. It was I'm just excited to have NTAA working together with us, the TAM Center and the steering committee on getting this put together. It was a great quick update from Ron, as well as what Leech Lake's been doing. Like I said, I was really excited to see Brandy and Ben kick off that pilot study they're doing, and hopefully what they learn, the tribal country will learn too, and we can utilize their knowledge to move forward on some more studies out there and really help the tribes on seeing some of those issues firsthand. So.
Yeah, agreed, Greg. So,
Andy, this is Brandy.
Go ahead.
Just had a comment of, I really want to caution tribes out there. This is really neat technology. It's frustrating at times, but when it works, it's pretty neat on what it's doing. But as Ron pointed out, and as everyone else has pointed out, we still don't know the accuracy, the bias and precision of these things and what's going on with them. And I just want to caution everybody that don't let funding agencies or even your own bosses and supervisors or whatever to push you towards these things because they're so cheap. They could be cheap for a reason, and we're still in that study phase, as Ron points out so eloquently, that we still don't know about these, and they are not replacements for FRMs or FEMs at this point. And it's a concern that I've heard throughout when we talk about this in sidebar conversations or whatever. I've heard like, oh yeah, such and such is pushing me this way because, it's $3,000, but it's $3,000 for a unit that may be only good for 2 years. These have life expectancies really short, where our FRMs out at the air site have been going since 2001. Not without issue, but they've been going on because they're just built differently. So that's just something I want to caution you and push back on these because this is not verified data yet.
Yeah, Randy, thanks for that. I think one of the questions I had, it just seems like the housing units for these sensors need to really be thought out in terms of the weather. And I saw your high-tech umbrella over your laptop there. So have you guys had any issues with, because Ron showed that kind of chicken box with the wiring, and then you had kind of the umbrella type structure. Have you seen any big differences in how they're housed?
I'll speak first, and then Ben can. I mean, that walk is pretty huge. It really is just a commercial-sized walk flipped upside down, and it hasn't let any snow go up and sit up in there. So they're moisture, they're exposed wonderfully, but yet they're protected from the moisture. We haven't seen any wind issues or anything like that. We've had more problems with the computer functioning correctly out there, and we've even thrown around the idea just recently this week, because we have such a cold spell coming, of throwing in a small heater in that white enclosure. But also we don't want to fry the thing out and melt everything either, so we're looking into that. Ben, did you have anything more?
No, I think that a lot of these studies are really in their infancy, and that neighborhood monitor is kind of self-contained and already
plug and play.
Yeah, exactly. Whereas a lot of these sensors are designed to be hung around your neck and worn around indoors, and they're just not designed for, especially a Minnesota climate or any other climate where you're going to run into rain and wind. So, not really is the answer I have.
Yeah, because it seems like with folks working in different parts of the country, the weather could really be an impact on how they operate.
Most definitely. I think that is huge.
Great. Ron, do you have any closing thoughts?
I think Ron had to jump off the call and attend another meeting.
Right. How about you, Amanda? Any other closing thoughts?
No. Just like Ron said, we are here. If anybody has any questions, feel free to get in touch with us, and we are happy to help out. And good luck.
Great. Thanks. And before we close the call, I just wanted to alert folks to some of the NTAA resources that are out there. On our main website here, we've just updated a new website called the STAR web page. Status of Tribal Air Report is something that NTAA produces every year. And to kind of boost that, we produced this additional website. And this has some interactive maps for you. I just wanted to highlight the Air Quality Monitoring and Tribal Air Programs interactive map here. So this has different data points for all kinds of different things related to tribal air programs. It's got different monitoring sites, and this I have up here right now selected the ozone monitors, but you can add layers, including mercury deposition network sites, things like that. So you can just play around with this if you want to get some more information on what's going on at air quality monitoring sites in your neck of the woods. NTA has this resource for you. This also has a link to EPA's EJ screen, which also has a lot of data points on air quality and other environmental points on it. And we also have a map for energy development and transport data points as it relates to energy sources and pipelines and all kinds of stuff that you might be interested in. It also has access to the actual report and other things like that. So I just wanted to make sure folks knew about that. Before we close, I just wanted to see if there was any other closing thoughts or questions that folks had. No? We'll want to thank everyone for their time today and enjoy your monitoring out there. Thanks, everyone.